Hello everyone, and welcome to a limiting reagent worksheet explanation in stoichiometry. On this worksheet we went through the first question on the front of the page together, and then we look at the back of the page and we see that we have two questions with A, B, and C to answer for them. So let's do that together. Number one, it says consider the following reaction. We have ammonium nitrate plus sodium phosphate is giving us ammonium phosphate and sodium nitrate. The first thing you should do in this problem is make sure that it's balanced, and you will see that it is. We have a 3 to 1 to 1 to 3 ratio. Fantastic. Now I would suggest you take a moment, maybe pause the video, and calculate the molar mass for each of the reactants and each of the products. For ammonium nitrate, you should have 80 grams per mole. For sodium phosphate, you should get about 164 grams per mole. On my product side, for ammonium phosphate, you should get 149 grams per mole. And for sodium nitrate, around 85 grams per mole. I say around because it really depends on how you round. So each person's answer might be slightly different, but not by much. So it really depends on how you round, but these are the numbers that I got and that I'm going to use. Cool. So I like to write those above. If you're one of the lucky ones that got a copy of my sheet with all of my work on it, you'll see that I wrote them above so that I can keep referencing them throughout the problem. I'm going to go with yeah. Cool. So it says answer the question above, assuming we have started with 30 grams of ammonium nitrate and 50 grams of sodium phosphate. So which product am I going to now look at? All right, I'm starting with 30 grams of ammonium nitrate, 50 grams of sodium phosphate, but I've got two products to consider here. So when I'm looking at what is my limiting reagent or what is my limiting reactant, the first thing I'm going to do is actually solve for both products. And of course, we'll have to use the ratio as well and find out how much can I possibly produce. So for the very first one, for 30 grams of ammonium nitrate, we'll start off with 30 grams of ammonium nitrate, so NH4, NO3. First step is to convert that to moles, so times, grams is on top here, so I have to put grams on bottom. So in 1 mole of this, I look above and I can see, well, we wrote 80 before, so we have 80 grams per 1 mole. All right. You guys can write out the rest. Write ammonium nitrate here, write ammonium nitrate here. I don't have enough space to continue. All right, and those will eventually cancel out. Here I'm going to put my ratio box. And our first product that we're going to consider is ammonium phosphate. When I look at this is now my ratio box. When I look at the ratio, I see that in my balanced equation, I have 3 moles of ammonium nitrate, and I only have 1 mole of ammonium phosphate. Again, I would tell you to write the whole thing out here. So on the bottom, we have ammonium nitrate, and on the top we have ammonium phosphate. Okay, Those all cancel out. Then our final step is to convert that to grams. So in 1 mole of ammonium phosphate, I'll try to write it here, NH4 3PO4. In 1 mole of it, I have 149 grams. You're going to multiply across, so 30 times 1, I think that's 30, times 1, I think that's 30, times 149, you're going to get a pretty high number, and then you're going to divide that by 80 times 3, whatever that is. That would be 240. So multiply the top numbers divided by this, and you should get 18.6 grams of ammonium phosphate. Cool. So that's for the ammonium phosphate. Now I have to look at my other product, which is sodium nitrate. So how much of that can I make? Let's do it again. And again, I'm trying to find out how much can I possibly make looking at 30 grams of ammonium nitrate. So NH4NO3. Again, I'm going to do my second step, converting this to moles. So that's going to be 1 mole is 80 grams. Here's my ratio. To get rid of it, I have to put it on bottom. They canceled out here, the grams. Right, grams of ammonium nitrate, grams of ammonium nitrate. Here's moles of ammonium nitrate. Again, I'm not writing it out because I don't have much space, but you should, through all the examples we've had, you should know that by now. So since I have ammonium nitrate up here, I have to write it down here. And in my ratio from my balancing, I have 3 moles of it. That the unit's going to cancel. So units cancel, but I still leave the number 3. And now I'm looking at the other product, which is sodium nitrate. I already solved for ammonium phosphate. This time I'm looking at ammonium nitrate, and it looks like I should have 3 moles of, I might have some space here, NaNO3. All right. And then I got to convert that to grams. So in 1 mole of NaNO3, I have 85 grams. NaNO3. Moles of NaNO3 cancel, mole NaNO3 cancel. You're going to multiply 30 times 1 times 3 times 85. That's going to give you a number that you can put here. And I'm going to divide that by 80 times 3, which should be 240. Yeah. Your answer should be 31.87 grams of NaNO3. Believe it or not, we are now only halfway done with answering A. Alright, so now I found out how much product I can make possible if I have 30 grams of ammonium nitrate. Now we need to do the same thing for the other reactant, which is sodium phosphate. So we'll quickly do that. I now have 50 grams of sodium phosphate. And I want to find out, again, how much of each product I can possibly make. So 50 grams of Na3PO4. I'm going to convert that to moles. In 1 mole, I have how many grams of this? I have... Every time I make a movie, it's you that interrupts me. Mm-hmm. Unbelievable. It's okay, it's okay. 50 grams of sodium phosphate. I have 164 grams. Here's going to be my ratio. Grams of sodium phosphate cancel with grams of sodium phosphate. Moles of sodium phosphate. I need to put them down here. So how many moles of sodium phosphate are there in this ratio? This is moles, this is moles. And my first product I'm looking at here is ammonium phosphate. NH4, and that's in parentheses. I got 3. I'm going to continue here, PO4. Ammonium phosphate. The ratio, it looks like it's going to be 1 to 1. Fantastic. Moles of NaPO4 are going to cancel out with moles. Now I need to convert this ammonium phosphate to grams. So in 1 mole of NH4 3PO4, I have how many grams? We already calculated that I should have 149. Cool. This cancels, everything cancels. You're going to do 50 times 1 times 1 times 149. You'll get a beautiful number, and then you'll divide that by 164 times 1 times 1. So whatever number you got for the top, I don't have a calculator with me now, but you're going to divide that by 164, and that should give you 45.43 grams of ammonium phosphate. I can already see, if I compare it to the first thing that we did, seeing how much of ammonium phosphate could I make with 30 grams of ammonium nitrate. For that, I got 18.6 grams. If you look up, that's the first thing we did. So if with 30 grams I can make only 18.6 grams of ammonium phosphate, but with 50 grams of sodium phosphate, I can make this much. So clearly, already I can now answer A for what is limiting me, what's holding me back, what's going to be the lower number. It's this. So which reactant is my limiting reagent? You can figure it out right now already, which is going to be ammonium nitrate. Cool. Just for the purpose of finishing calculations, we'll look at how much of the other product I can make with 50 grams of sodium phosphate. But we've already discovered our limiting reagent. What's holding me back? So we have 50 grams of Na3PO4. Convert that to moles. In 1 mole of this, we have 164 grams. It's going to be my ratio box. If I have 1 mole on top of sodium phosphate, I can't stress enough for you to write it out. So this is sodium phosphate. Sodium phosphate has to go down here too. Na3PO4. All right. And my second product is sodium nitrate, NaNO3. What's the ratio between the two? It looks like I have 3 moles and 1 mole here. Cool. And then I'm going to convert that to grams. So in 1 mole of sodium nitrate, I have 85 grams. Multiply across, you'll get 50. Once that goes away, 50 times 1 times 3 times 85. I'm going to put that as X. Divided by 164 times 1 times 1. That's 164, which will equal 77.7 grams. So now of NaNO3. So now I've figured out everything that I could possibly make with both reactants, with the amounts I'm being given. And a quick summary of that is with 30 grams of NH4NO3, I can make 18.6 grams of ammonium phosphate, and I can make a total of 31.87 grams. If you rounded that to 31.9 or even 32, it's not the end of the world. NaNO3. And with 50 grams of sodium phosphate, I can make 45.43 grams of ammonium phosphate and 77.7 grams of sodium nitrate. That's what we discovered. And we've already decided that, hey, ammonium nitrate is the limiting reagent. Reagent is a fancy word for reactant. So this is what's limiting me. So that's my answer for A. A is asking you, what is your limiting reagent? Well, I got it. B is saying, what is the maximum amount of each product that can be formed? Well, because this is what's limiting me, this is what's going to allow me to make a certain amount of product. So I can only make 18.6 grams of ammonium phosphate. I can only make 31.87. Even if I had 1,000 grams of this stuff, if I had 1,000 grams, it doesn't matter. It can only react with 30 grams of this, of ammonium nitrate. So that's what's limiting me here. So your answer for B is 18.6 grams of ammonium phosphate and 31.87 grams of sodium nitrate. To answer C, this is where we have to learn our special rule of today. Well, depending on when you're watching this. I'll say when we lectured about the worksheet. So in order to do this, it says how much of the other reagent, by that meaning not the limiting reagent, the non-limiting reagent, is left over. Well, if ammonium nitrate is the limiting reagent, the non-limiting is sodium phosphate. In my problem, it says that I started with 50 grams. I started with this much. In order to find out how much extra I have to find out how much did I use. And what I'll do is I'll subtract from this 50 the amount that I had times a ratio of my limiting reagent, how much I was able to make in a product for my limiting reagent, and how much product I was able to make with my non-limiting. So in this case, you could actually pick either one. For simplicity purposes, I'm going to pick 18.6. So we'll focus on the ammonium phosphate. My limiting reagent, I was able to make 18.6, and I'll divide that by how much was I able to make with sodium phosphate. I was able to make 45.43 grams. Cool. So what this is going to tell me is how much I used. and it will then give you an excess. So 50 minus this, your answer should be 29.5 grams of Na3PO4. And this is for C. Now, the bottom one, number 2, is solved the exact same way. I'm making a movie. 1 second. So the bottom one, number 2, is solved the exact same way. But I'll give you the molar masses. So if you look at calcium carbonate, where you see the 3 there, looks like the ratio is 3 to 2 to 1 to 1. That's pretty simple. If you look at calcium carbonate, I would write 101 grams per mole. That's what I got there. For the iron 3 phosphates, I have 151 grams per mole. And I would suggest to check these. Try to solve it yourself, because on the test I don't give them to you. For the calcium phosphate, I have 313 grams per mole. And for the iron 3 carbonate, I have 292 grams per mole. All right. Work them out and solve them, but for the first one, it says I have 100 grams of calcium carbonate. All right, so for calcium carbonate, if I look at how much of each product, my 2 products are calcium phosphate and iron, what is that, iron 3 carbonate? Yeah, for those 2 products, I was able to calculate that we were able to make 103.3 grams of calcium phosphate and 96.4 grams of iron 3 carbonate. And for my other reactant, which is FePO4, I was able to make 46.6 grams of calcium phosphate that's 2, and 43.5 grams of iron 3 carbonate. Now clearly here you can see that with iron 3 phosphate, I made less. So this is my limiting reagent. So this is the answer for A. This is my limiting reagent. For B, how much maximum product can we make? Because this is holding me back, I can only make these amounts. So this is B. And to solve for C, erase this for a moment. To solve for C, we're going to take a look at my non-limiting reagent, which in this case was calcium carbonate. We started with 100 grams of calcium carbonate, right? We started with 100 grams minus 100 times a ratio of our limiting reagent, the amount of product we were able to make with a limiting reactant, and our non-limiting reactant for a specific product. So it really doesn't matter which one you pick, but in this case we'll pick our first product, which was calcium phosphate. So our limiting reagent of iron 3 phosphate, we were only able to make 46.6. And our non-limiting reagent, we were able to make 103.3 grams. When you multiply these out, you should get an answer that you have 54.9 grams of calcium carbonate that is remaining or in excess. If you have any questions about this or how to solve it, please make sure to subscribe and comment below and like. And you can also email me